So, I want you to picture something for a second. Imagine it's like the absolute dead of July.
Oh, the worst heat of the year.
Right. A massive heat wave is rolling through your town, so you walk over to your thermostat and you crank your house's central air conditioner to full blast. And then, you just leave it there.
Just completely abandoned it on high.
Yeah. Not just for the afternoon or the weekend, but for weeks, all summer long. You never let that system cycle off. And I mean, you can probably visualize exactly what's going to happen.
Oh, yeah, the motor's going to start whining.
Exactly. The motor whines, the condenser coils are going to freeze over into a solid block of ice, and eventually the entire system is just going to catastrophically fail from the cumulative air and tear.
It has to, yeah.
So if you're listening to this right now, have you ever considered that your body is doing the exact same mechanical breakdown when you spend months on end stressing over work or your relationships or your finances?
That is honestly a phenomenal analogy.
Yeah.
Because, it moves us away from thinking about stress as just this fleeting emotion, and it frames it as a literal mechanical load on a biological machine.
Right, a machine that's wearing down.
Exactly. And that's actually the entire focus of our deep dive today. And to tackle this, we're going to lean into a specific dynamic here. I'm going to act as the lecturer today, laying out the biological architecture and the historical data.
And I'll be taking on the role of the student. So I want to synthesize these concepts, push back where things seem a little murky, and really figure out the practical implications for all of us listening.
That sounds like a perfect plan. So our curriculum for this session comes directly from section 14.3 of chapter 14 from Psychology 2E.
Awesome.
Yeah, and our primary mission is to map out the physical mechanisms, the actual biology of how psychological stress creates and accelerates physical illness. The clinical term the textbook uses here is psychophysiological disorders.
Psychophysiological disorders. Okay, but before we get into the specific illnesses, I feel like we need to address the underlying design flaw.
What do you mean?
Well, from an evolutionary standpoint, the human body is incredibly resilient, right? So why does a modern psychological stressor like, I don't know, worrying about a mortgage cause the machine to break down? It seems like we should be adapted to handle daily pressures.
Well, you have to look at the environment our bodies actually evolved in. Which brings us to the core insight of stress researcher Robert Sapolsky.
Okay.
The biological cascade we call the stress response was forged in an environment of acute physical emergencies. So the classic evolutionary scenario is encountering a predator, like a bear on the trail.
A literal life or death moment.
Exactly. In that moment, your body executes this flawless, highly coordinated survival program.
Right. So the sympathetic nervous system kicks in, your adrenal glands are just dumping epinephrine and cortisol into your bloodstream, your heart rate spikes to pump oxygen to your major muscle groups, your pupils dilate, you are entirely optimized to fight or run.
You're a machine ready to survive.
Mm-hmm.
And crucially, that intense biological mobilization is meant to last, maybe 5 to 10 minutes?
Right. It's short.
Yeah. You either outrun the bear or, you don't. But the emergency resolves quickly. And if you survive, your parasympathetic nervous system kicks in and brings the body back to a baseline state of rest.
So it turns the air conditioner off.
Precisely. It cycles off. The design flaw, as Sapolsky argues, is our modern environment. We activate that exact same primal survival program while sitting perfectly still in traffic.
Oh, man.
Or agonizing over an email. We flood our bloodstream with cortisol, but instead of burning it off in a sprint, we leave the tap running for months.
Wow, so we are basically revving the engine into the red line while the parking brake is engaged.
That's it, exactly.
But, okay, as the student trying to map this to everyday life, I have to wonder where the clinical boundary actually is. Because, a healthy burst of adrenaline before a big job interview is actually helpful.
Right, it sharpens you.
Yeah, so when does that cross the line into a full-blown psychophysiological disorder?
So the clinical distinction relies on actual tissue damage or measurable dysfunction. A psychophysiological disorder is defined by physical symptoms that are objectively real.
So we aren't talking about hypochondria here.
No, not at all. If someone has a stress-induced ulcer, the hole in their stomach lining is physically there. But the root cause, or at least a significant worsening factor, is the chronic psychological load.
Got it.
And when we look at who carries the heaviest chronic load, the data points overwhelmingly to social and environmental factors.
Yeah, that makes total sense. If you're constantly navigating an unpredictable environment, your brain just never receives the all-clear signal to shut off the stress response. And I notice Section 14.3 dives pretty deeply into this, specifically regarding social status and resource inequality.
It does, yeah. Researchers like Sapolsky and Michael Marmot have demonstrated that a person's position in a social hierarchy is actually a profound predictor of disease. Moving through the world with lower social status usually equates to a massive loss of predictability and control. You have less autonomy at work, less financial buffer for emergencies, and often just less access to supportive infrastructure.
Right, and the textbook provides some very stark demographic data to illustrate those systemic disparities here in the United States.
Yeah, it does.
Like, it highlights that African-American women experience the highest rates of emergency room visits and unmet healthcare needs compared to any other demographic group. And it also points out that lesbian, gay, bisexual, and transgender youth frequently report poorer quality of medical care, which is often tied to systemic stigma or, just a lack of clinical understanding from providers.
Right, and taking those findings objectively, just looking at the textbook's data, the biological takeaway is that systemic social issues like stigma, ostracization, lack of resources, they act as permanent environmental stressors.
Because you can't just run away from them.
Exactly. They force the individual's nervous system into a state of chronic hypervigilance. The bear is never off the trail, right? The bear is the environment itself.
Man. Okay, so we have a clear picture of the evolutionary mismatch, and we understand that chronic hypervigilance leaves the engine running hot.
Yeah.
Now we need to bridge the gap between a psychological state and a physical breakdown. Let's start with the body's primary defense network, the immune system.
Okay, let's do it.
If I'm stressed about my social standing or my job, how does my thought process actually dismantle a white blood cell? Like, I need hard proof of this.
It's a fair question.
Yeah.
And to map that out, we look at the field of psychoneuroimmunology.
That is quite the word.
I know, it's a mouthful. But basically, the immune system is essentially your body's microscopic surveillance and security force, right? It differentiates your healthy cells from foreign invaders like bacteria or mutated cancer cells.
Okay, so it's the security guards.
Right. And when it malfunctions, it either goes rogue and attacks your own tissue, which results in autoimmune diseases like rheumatoid arthritis or lupus.
Right.
Or it experiences immunosuppression, where the security force simply stops patrolling, leaving you completely vulnerable to outside infection.
And the assumption for a long time was that the immune system operated autonomously, right? Like an independent contractor that didn't take orders from the brain.
Exactly. That was the prevailing medical dogma for decades. But that changed radically in 1975 with an experiment by Robert Ader and Nicholas Cohen involving rats.
Okay, what did they do to the rats?
So they administered a sweet, saccharin-flavored water to the rats and simultaneously injected them with a drug that aggressively suppressed their immune function and induced severe nausea.
Oh, wow. Okay, so if we follow the logic of classical conditioning here, the rats are going to associate the taste of the sweet water with feeling terribly sick.
Right.
They'll develop a taste aversion just
Yeah,
naturally?
they developed a profound aversion, yeah. But Ader and Cohen took it a step further. Later on, they force-fed the rats the sweet water without the immunosuppressive drug. The moment the rats tasted the saccharin, their immune systems instantly shut down. The white blood cell count just plummeted.
Wait, really? Just from the taste. That is essentially Pavlovian conditioning, but happening on a microscopic level.
Yes, exactly.
Just like Pavlov's dog salivating at a bell, the rat's brain learned to send a stand-down order to its own bone marrow just from a flavor cue. That implies a direct, hardwired communication cable between the central nervous system and the immune system.
That's the huge breakthrough. It proved that the brain and the immune system are physically linked. We now know that sympathetic nerve fibers actually drop directly into immune organs like the spleen and the thymus gland.
No way.
Yeah. And furthermore, white blood cells actually have receptors for stress hormones on their outer membranes.
Wow.
So when you are chronically stressed, the cortisol in your bloodstream physically binds to those lymphocytes and signals them to stop reproducing or even to undergo apoptosis, which is cellular suicide.
That is an absolutely terrifying mechanism. Your brain floods the body with cortisol to survive a perceived threat, and the cortisol actively kills off your internal security force.
It's totally counterproductive long term.
Let's bring this out of the rat lab, though, and into the human experience. How does this immunosuppression play out when we are dealing with everyday human stressors?
The best illustration of this is a landmark 1998 study by Sheldon Cohen.
Okay.
He and his team gathered 276 healthy human volunteers. They conducted exhaustive interviews to map out every stressor in these people's lives.
Got it.
And then they administered nasal drops containing a live rhinovirus.
Wait, the virus that causes the common cold?
Yes, directly into their noses.
They paid people to let scientists intentionally infect them with a respiratory virus.
$800 a person.
That is wild. I mean, I assume the goal was to see if the psychological profiles predicted who actually developed symptoms from the physical exposure?
Yeah, precisely. Everyone received the exact same viral load, but not everyone got sick. And the deciding factor was the duration of the psychological stress they were carrying.
So how long they'd been stressed?
Right. Participants who had been enduring a chronic stressor, specifically a stressful work environment or severe relationship friction lasting longer than 1 month, were significantly more likely to catch the cold.
You know, the textbook uses an analogy here that I think crystallizes the mechanism perfectly.
Oh, the night analogy.
Yeah, it points out that stress isn't the sword that kills the knight. Stress is the sword that breaks the knight's shield.
It's so good.
Because the rhinovirus is what actually causes the infection, but the chronic relationship friction is what shattered the immune shield so the virus could invade uncontested.
It's a vital distinction. And honestly, a cold is a relatively minor consequence of a broken shield. We also have to examine how this chronic activation alters our biology at the deepest structural level, our DNA.
Oh, wow. Okay.
Yeah. In 2004, researcher Alyssa Eppel began pioneering work on telomeres.
Telomeres. Okay, so if you are listening to this and trying to visualize a telomere, think of the little plastic aglets on the ends of your shoelaces that keep the fabric from fraying.
Perfect visual.
Telomeres are those protective caps on the ends of our DNA chromosomes. And every time a cell divides, those caps get shaved down just a little bit, right?
Exactly. And when those telomeres get too short, the cell enters a state called senescence. It can no longer divide, it becomes inflammatory, and it basically accelerates the biological aging process.
So it's literally aging.
Yes. And Apple's team wanted to know if chronic psychological stress could speed up that cellular fraying. So they studied a demographic enduring one of the highest prolonged stress loads imaginable mothers, providing full-time care for chronically ill children.
Oh, man. I mean, if stress hormones inhibit cellular repair, those mothers must be showing biological wear and tear that far outpaces their chronological age.
The results were staggering. They compared them to a control group of mothers with healthy children. The longer a mother had been caring for her ill child, and the higher her self-reported perceived stress.
Yeah.
The shorter her telomeres were. The most highly stressed mothers possessed telomeres equivalent to women who were 9 to 17 years older than them.
Wait, 9 to 17 years older. So holding on to chronic stress is literally fast-forwarding your biological clock by up to a decade and a half.
Yes. It's aging them on a cellular level. And subsequent studies reveal that this accelerated ticking can start incredibly early.
Like in childhood.
Exactly. Exposure to severe childhood trauma violence, profound family conflict, abuse can begin eroding telomere length long before a person even reaches adulthood.
That's heartbreaking.
The psychological burden of early adversity physically degrades the structural integrity of their cells.
So we are seeing a cascading failure here. The immune shield drops, the cellular DNA frays, and ages prematurely. And if we follow this mechanical breakdown, the body's main engine, the cardiovascular system, has to be taking massive collateral damage from pumping all this inflammatory, stress-laden blood.
The heart is the primary casualty.
Yeah.
Absolutely. And our understanding of how psychology destroyed the heart actually stems from a completely serendipitous observation in the 1950s by a cardiologist named Meyer Friedman.
What did he notice?
He was inspecting the furniture in his waiting room, preparing to have it reupholstered.
Okay, reupholstery. How does that connect to heart disease?
Well, the upholsterer pointed out a bizarre pattern of wear. The chairs were only worn out on the very front edges of the seat cushions and the front tips of the armrests.
Oh, because his cardiology patients were in such a state of chronic agitation that they were literally sitting on the edges of their seats.
Gripping the armrests, yes.
Unable to relax even in a waiting room.
Exactly. Friedman and his colleague Ray Rosenman realized that their heart disease patients shared a distinct behavioral cluster. They were intensely driven, highly impatient, and perpetually rushing against the clock. They coined this the type A behavior pattern, contrasting it with the more laid-back type B personality. Initially, their data suggested that simply being a driven type A workaholic increased your risk of heart disease by over 7 times.
Over 7 times. But wait, science rarely settles on the first draft, right? Being a busy, ambitious person doesn't automatically doom your heart. It has to be a specific component of that type A drive causing the physical damage.
You are correct, and later research refined the model significantly. It is not the busyness or the ambition that kills the heart. The lethal component embedded within the type A profile is anger and hostility.
Okay, we really need to explain the how here. Why does holding on to anger cause a physical blockage in an artery?
It comes down to fluid dynamics and tissue damage.
Okay.
When you experience a surge of hostility, your sympathetic nervous system dumps epinephrine into your blood. Your heart rate skyrockets and your blood vessels constrict. Suddenly, your blood is pumping through your coronary arteries at a highly pressurized, turbulent rate.
Like a pressure washer.
Exactly. Imagine a fire hose blasting away at a delicate surface. That turbulent, high-pressure blood flow actually scours the smooth inner lining of your arteries, creating microscopic tears.
Ouch. And the body responds to a tear by sending inflammatory cells to patch it up, right? But if you have cholesterol in your blood, that cholesterol gets trapped in the tears, forming a plaque.
Right.
Over time, that plaque grows, the artery narrows, and eventually it occludes completely, and you have a heart attack.
That is the exact mechanism. Anger mechanically damages the plumbing, and the data backing this up is immense. One longitudinal study tracked over 1,000 male medical students from their early 30s until they were 48 years old.
What did they find?
The individuals who scored the highest for anger on initial questionnaires were over 6 times more likely to experience a heart attack by age 55 compared to their less angry peers.
6 times more likely, just from being angry. And, reading through section 14.3, they outline something called the transactional model of hostility to explain how this anger sustains itself.
Yes, the Caitlin example.
Right. They use a hypothetical character named Caitlin. And if you are listening to this and mapping your own morning commute or workplace dynamics onto Caitlin, it becomes clear that hostility is basically a self-fulfilling echo chamber.
Walk us through Caitlin's loop. How does she manufacture her own cardiovascular load?
Well, Caitlin possesses a hostile, cynical disposition. The textbook describes her taking a shower in the morning, already mentally rehearsing arguments and imagining retaliating against people who haven't even annoyed her yet.
She's waking up fighting.
Exactly. She preloads the stress response. So because she is carrying that aggressive posture, she goes to work and uses a harsh, confrontational tone with a coworker. The coworker, understandably, snaps back or avoids her.
Naturally.
But in Caitlin's mind, that negative reaction doesn't register as a consequence of her own tone. It registers as proof that the world is entirely populated by antagonistic jerks.
It reinforces her core belief.
Exactly. She creates an antagonistic environment which justifies her hostility, which keeps her blood pressure spiked, which creates more arterial microtears. The psychological disposition forces the environment to react negatively, creating this perpetual motion machine of cardiovascular stress.
It is a devastating cycle. But we also have to recognize that pushing stress outward as anger isn't the only way to destroy the heart.
What's the other way?
Turning that psychological weight inward in the form of depression is equally lethal.
Really?
Yeah. A 1996 study by Barefoot and Schroll tracked residents in Denmark and found that patients with the highest depression scores were 71% more likely to experience a heart attack than those with lower scores.
A 71% increase. That makes depression a primary mechanical risk factor.
It does. In fact, the American Heart Association now officially recommends depression screening as a standard protocol for patients, treating it with the exact same clinical gravity as high cholesterol or obesity.
Wow. So we have the heart failing under the weight of hostility and depression, but I want to pivot to the respiratory system for a second because the statistics on asthma are alarming.
They really are.
Between the years 2000 and 2010, asthma rates surged by 157%. If asthma is an inflammatory disease of the airways, how does a purely psychological event trigger a physical lung obstruction?
To understand a physical trigger, we have to look at the neurology of the lungs. The smooth muscles surrounding your airways are innervated by the vagus nerve.
Okay, the vagus nerve.
Which serves as a major communication highway between your brain's emotional centers and your visceral organs. In an asthma attack, the airway walls become inflamed and thicken, while those smooth muscles simultaneously spasm and tighten. It makes expelling air incredibly difficult.
Right, and I can easily see how inhaling pollen or smoke would cause local inflammation. But you are saying that a surge of emotional distress in the brain can travel down the vagus nerve and command those lung muscles to aggressively clamp shut.
Precisely. High levels of negative emotion and anxiety have been proven to severely disrupt airway function. The textbook highlights a fascinating case study from 2010 that perfectly illustrates how modern digital stressors tap into this ancient physical pathway.
The Facebook case study, this blew my mind when I read the mechanics of it.
It's wild. It involved an 18-year-old man suffering from severe asthma.
Right.
This young man had recently gone through a painful breakup. His ex-girlfriend unfriended him on Facebook, but eventually they reconnected on the platform.
Okay.
The clinical observation was astonishing. Every single time he logged on and viewed her profile, his airways would constrict. He would suffer an immediate asthma attack.
Wait, an asthma attack just from looking at a digital image on a screen?
Yes.
That is unbelievable. So his visual cortex processed the image of his ex. His amygdala registered profound emotional distress, and that signal fired down the vagus nerve to physically paralyze his respiratory system. The digital cue basically became the bear on the trail.
That is exactly what happened. The emotional pain translated instantly into a biological obstruction.
Right.
And when he finally made the decision to quit the social media platform entirely, the asthma attack ceased. It demonstrates that the body does not distinguish between a physical threat and a profound emotional threat. It reacts with the same blunt force physiological tools.
That is so wild. And, it isn't just the heart and lungs absorbing these blows. We know that chronic stress drastically amplifies our overall sensitivity to pain, too.
Oh, definitely.
It lowers the threshold for pain pathways to fire, which is why psychological stress is the primary trigger for tension headaches. The textbook notes that tension headaches account for roughly 42% of all headaches globally.
That's a massive percentage.
Your brain feels threatened, so it signals the muscles in your neck and scalp to permanently clench.
It is the ultimate manifestation of the body physically bracing for an emotional impact. The musculoskeletal system locks down, the immune system stands down, the heart pumps against high resistance, and the DNA fraying accelerates.
It's a full system alert.
Well,
So, stepping back to synthesize all of this for anyone listening, the
Okay.
central revelation here is that your mind and your body are not two distinct entities sharing an apartment.
No, not at all.
They are a single, continuous physical system. The psychological weight of harboring resentment or ruminating over a financial crisis or dealing with systemic ostracization, that psychological weight has literal physical mass.
Yes, yeah.
It is a mass that scours the inner lining of your coronary arteries, it commands the muscles around your lungs to seize, and it physically erodes the protective telomeres on your genetic code.
That is a flawless summary of the mechanisms at play. The damage is not metaphorical, it is measurable down to the cellular level, which leaves us with a final, somewhat provocative concept to consider as we wrap up.
Let's hear it.
If your biology has not evolved past reacting to a stressful text message the exact same way it reacts to a hungry predator on the trail,
Yeah,
you cannot simply wait for your environment to calm down.
right, because it never will.
Exactly. So, how might you need to actively hack or manually override your own physiology every single day through breathwork, movement, or boundary setting just to convince your own nervous system that you are actually safe?
Wow, that is the million-dollar question for all of us navigating the modern world. Well, thank you for joining us on this deep dive. And if you are listening to this right now, before you let that mental air conditioner grind away on full blast for another week, maybe figure out how to reach over, flip the switch, and let the system cycle off.